So dear students, now let me discuss about volume integration. Okay, we have just finished surface integration and this is the last topics of actually vector integration. Okay, and now after finishing this volume integration we will move to the integration theorem, that is Green's theorem, Stokes theorem and divergence theorem. We will discuss that part of the vector calculus and that will be the last part of the vector calculus. Okay, so this is actually the last topics of vector integration. Okay, and that is volume integration, because you have discussed already line integration and surface integration. This is volume integration. Okay, so we have already discussed about surface integration and line integration. Now let me define volume integration, and actually this is nothing but triple integration. We have already discussed this triple integration in the topics of single and multivariable calculus. You can go through the playlist and you can see the videos from there. That is the very basic topics of mathematical physics of IDGM. Okay, and this is just as convention I have discussed. I'm going to discuss here volume integration, but it is not needed actually, because whatever we do here we have already done in triple integration. Okay, so now as convention we have discussed line integration, we have discussed surface integration, so I'm going to discuss about volume integration. But everything that I'm going to tell you here, more or less I have discussed in the chapter triple integration. Okay, so let me define first volume integration. And as this is the topics of vector calculus, so you can see here that a vector function is also involved, but on that topic I have involved the scalar function f. So I have already discussed about this kinds of situation, that is volume integration f dv. But the new thing that you are going to face here is this vector sign here. Instead of a scalar function, sometimes we need to define the triple integration for vector function also, and that is integration a dot adv. Okay, adv. So what is the definition of volume integration that I have written here? Consider a closed surface in space enclosing volume v. Suppose we have a closed space like this, and this space enclosed a volume v, then we can define volume integration like this in this region. Okay, whatever be the function, maybe the scalar function f or the vector function a. Okay, the function is defined in this region, in this bounded region. Okay, so whenever there is a volume, there is obviously a closed surface or the closed space. So the volume integration is defined for this closed space here. Okay, so now let me solve some questions involving this integration notation, that is triple integration or the volume integration adv or fdv. Okay, then you can you will be very clear about the procedure of the how you have to do the integration. Okay, because the definition is very simple. This is dv. Dv means in various coordinates it will be different. So if you talk about the Cartesian coordinate system, then this dv will be just dx dy and dz, dx dy dz. Okay, but if you talk about something polar coordinate, that is spherical polar coordinate, then dv will be r square sin theta, r square sin theta dr d theta d phi, dr d theta d phi. And if you talk about polar coordinate, cylindrical polar coordinate, then will be dv rho. Okay, rho 0 d phi and dz. Okay, because here the coordinate is rho phi z, and here the coordinate is r theta phi, and here the coordinate is xyz, x y z. Okay, so now let me solve some question on this topic. Okay, what is actually mean by this volume integration? You can understand only if you solve some of them. Okay, so this is the first question. Let me solve this question. Okay, so here given a scalar function f is equal to 45 x square. So let a be equal to 45 x square and let v denote the closed region bounded by the planes. This plane, that is 4x plus 2y plus z is equal to 8, x is equal to 0, y is equal to 0 and z is equal to 0. So these three plane, x is equal to 0, y is equal to 0, z is equal to 0, and this is the plane 4x plus 2y plus z is equal to 8, and we have to find out integration f dv. So if you want to draw the plane, you can do it. Okay, so this is just x axis, this is y axis, and this is z axis. What is x is equal to 0 plane? X is equal to 0 plane is this plane actually. this plane. Okay, so and what is equal to y is equal to 0 plane, y is equal to 0 plane, this is x is equal to 0 plane, yz plane, and y is equal to 0 plane is nothing but zx plane. Okay, that plane zx plane. And another one is z is equal to 0 plane, that means xy plane. Okay, that means xy plane, something like this. Okay, so when I'm going to draw this plane, that is 4x plus 2y plus z, it will be something like this, something like this. Okay, so this is the bounded volume, so bounded volume within this. Okay, so this plane, this 4x plus 2y plus z is equal to 8 plane, and x is equal to 0, y is equal to 0, z is equal to 0. So this is the bounded region, this is the bounded region, bounded volume. Okay, that we have to find out. So if you want, you can find out this point also, this point also. Okay, so you can write like this, this is 4x plus 2y plus z is equal to 8, and if you divide this 8, so it will be x by 2 plus y by 4 plus z by 8 is equal to 1. That means this point is 2, and this is 2 comma 0 comma 0, you can see 2 comma 0 comma 0, and this point is 0 comma 4 comma 0, and this point is 0 comma 0 comma 8, 0 comma 0 comma 8. Okay, now you have to choose dx dy dz, small volume element. So if I choose the small volume element here, that the surface is on xy plane. Okay, here this is the dx dy, and dz is along this direction, so here is the small volume element, you can say small volume element. Okay, that surface is dx dy, and its height is dz. So we can take here a small volume element, and that small volume element is dv. Okay, so the dv is here dx dy dz, dx dy dz. So what will be the integration? So if we want to solve this integration, volume integration, actually f dv, sorry, so f dv is nothing but the volume integration 45 x square y into dx dy dz, into dx dy dz. Let me solve it with proper limit. Okay, what is the limit of x? You can see the limit of x is, x will vary from, first you can see if this dx dy, so this dx dy will vary from here to here, actually here to here, or you can say the plane will vary, the you can find out the limit from here actually. Okay, if you don't understand the figure, if you understand the figure, then it's okay, but it is always very difficult thing to understand the figure for various kinds of plane given or various kinds of surface given. So that will be very difficult. You cannot draw each and every time the figure exactly. So there is a procedure that you can do the problem without using this diagram. So how you can do it? So you have to just you have to first find that j from head to head z is varying from head to head, but here you can see z is, the function is in this f is not actually function of z. Okay, so z will simply vary from 0 to 8. Okay, z will simply vary from 0 to 8 along this direction, but this is dx dy. So let me give you the diagrammatically first, then I will tell you how you can use the concept. Okay, so let me do it, otherwise you cannot get it. Okay, so let me tell you the actual thing. digit. So this will be our x-axis, this is our y-axis, this is our z-axis. You can see if this is xy plane, okay, this is xy plane, then your dx dy will be here. So if you see from here to the surface, okay, from here to the surface, and this is z. So here z is equal to 0, and here what is z? How you can find this from this equation? So you can find that we have 4x plus 2y plus z is equal to 8. Z is equal to 8. So what will be z? So z will be 8 minus 4x minus 2. So if you first convert z in terms of x and y, so you can find the limit of z. Because here z is 0, in this plane z is 0. So z is free from this to the plane, to the surface of the plane, and the surface of the plane, this is the surface of the plane. The surface of the each and every point of the surface is equal is above, is along the z axis, is above the xy plane. So above the xy plane, if you want to reach to the point of the surface, if you want to reach from xy plane to the point of the surface, then you have to go along z axis. And along which direction you should go? You should go from 0 to z. And what is z here? Z is 8 minus 4x minus 2y. Otherwise, if you want to do it in different way, you can do. If you take this xy, this instead of dx dy, you can take this plane also, zy plane. So if you take this zy plane as dx dy, then you have to move from this plane to the surface. Then you will move along x direction. You have to move along x direction. Then you will reach to the surface of the. You will reach to the surface of this plane. So in that case, you can see the limit of x. Okay, from 0 to 8 minus 2y minus z by 4. Because you have 4x equal, you have 4x plus 2y plus z is equal to 8. Z is equal. So if you want to see the limit of x, so you can get from here 8 minus 2y minus z divided by 4. So in that case, you can convert x in terms of z. So you have to put the limit of x in that case from 0 to 8 minus 2y minus z by 4. So if you want to integrate with respect to y first, then you can find also from here 2y. So you will get 2y is equal to 8 minus 4x minus z. 8 minus 4x minus z. So y will be 8 minus 4x minus z by 2. So in that case, you have to take this plane, okay, zy plane first. Then what you have to do? You have to move from this to this surface. Okay. So whenever you have to move from this xz plane to this surface, then you have to move along y direction. So you need the limit of y from 0 to this, because what you have to do actually in this integration, please understand. First, what you have to do, you have to choose just a plane, okay. Then from this plane, you have to move to the 4x plus 2y plus z is equal to 8 plane. So first, these planes are given. Actually, you can see x is equal to 0, y is equal to 0, and z is equal to 0 plane are given. So this plane are just flat plane, okay. X is equal to 0, y is equal to 0, and z is equal to 0. And then you have to choose any plane. Either x is equal to 0, or y is equal to 0, or z is equal to 0. So if you choose x is equal to 0 plane, okay, then what will be your plane? Your plane will be yz plane. So in that case, this is, suppose this is yz plane, then you have to take a single surface element dz dy. Then you have to move from this surface, that is x is equal to 0 surface, to this plane 4x plus 2y plus z is equal to 8. And you have to move in which direction? If this is yz plane, then you have to move along x direction. So you can do this integration by using any method. You can choose x is equal to 0 plane, y is equal to 0 plane, or z is equal to 0 plane. So what I am choosing here, the xy plane, that is z is equal to 0 plane. So I have chosen here first. You can see I have chosen here first this yz plane. So I have to move along z direction. So this is xy plane, and from here I have to move to the plane that is 4x plus 2y plus z is equal to 8. So if I want to move along z direction, so z will vary from 0 to that point, and that point is what? This is 8 minus 4x minus 2y. Okay, then you have to, what you have to do, you have to move first this point to this point, then you have to move this small surface element will move from this point to this point, then this element will move from 0 to this point, 0 to this point, 0 to 2. So the whole volume will be covered. Okay, so what is the steps you have to follow without drawing this diagram? This understanding is very important without using this diagram. So whenever you will get, let me give you the concept. Whenever you will get this kinds of volume integration, what you have to do first? First you have to choose the limit of z. Please keep in mind, always you try to put the limit of z. Okay, and how you can get the limit of z? From the surface given, and here the surface is what? 4x plus 2y plus z is equal to 8. So from here you have to first find out z. So you have to put the limit of z then. So z will be from 0 to this point, 8 minus 4x minus 2y up to this 0 to 8 minus 4x minus 2y. Then what you have to do? You have to then choose the limit of y. So first you have to choose the limit of z, then you have to choose the limit of y, and then you have to choose the limit of x. So how you can choose the limit of z? Just the plane that you are given. Sometimes this is given in terms of surface also. Here the plane surface, sometimes it is not necessary that always it will be a plane surface. So whatever surface you are given, first what you have to do, you have to just find out the z. What is z equal to? And z should be vary from 0 to that point. So it will give you the limit of z. Without knowing this diagram, you can find. Without knowing this diagram, you should just focus on this plane that is given, and you can see the initial limit from this, that is z is equal to 0, and the final limit will be z is equal to this 8 minus 4x minus 2y. Now what you have to do, you have to take the limit of y, and when you will take the limit of y, then you have to put z is equal to 0 here. Why you have to put z is equal to 0 here? Because you are now moving on xy plane. Okay, so your algorithm will be, first you have to choose the limit of z, then you have to put z is equal to 0 here. So whenever you will put z is equal to 0 here, what you will get? You will get just, please see, 4x plus 2y is equal to 8. So you will get from here the limit of y. So what will be the limit of y? 2y is equal to 8 minus 4x. So y will be just 4 minus 2x. Y will be 4 minus 2x. And the initial limit will be 0. So y will vary from 0 to 4 minus 2x. Are you understanding? 0 to 4 minus 2x. Now you should put the limit of x. And how you can find the limit of x? You have to put y is equal to 0 and z is equal to 0. So you will get just 4x is equal to 8. So x will be 2. This is how you can move. So without knowing this diagram, you can solve the integration by using this algorithm, by following this algorithm. So let me do it again so that you can understand. So what you have to do first, please see. We have a volume integration f dv, and f is given as 45x square y, and dv is dx dy dz. So I am going to solve this in Cartesian coordinate. So I need limit x, y, and z. So what we have just the equation of plane, that is 4x plus 2y plus z is equal to 8. 4x plus 2y plus z is equal to 8. So what we have to do, we have to first put the limit of z. So initial limit will be 0. So final limit will be from here, z is equal to 8 minus 2y minus 4x. Okay, so you have to put here 8 minus 2y minus 4x for z. And then what you have to do, you have to put the limit of y. So when you put the limit of y, you should put z is equal to 0. So if you put z is equal to 0, then limit of y will be 4x plus 2y is equal to 8. So 2y is equal to 8 minus 4x. So y will be 4 minus 2x. 4 minus 2x. So it will be 0 to 4 minus 2x. 4 minus 2x. Okay. And then finally you should put y is equal to 0, z is equal to 0. Then you will get 4x is equal to 8. So x is equal to 2. So x will vary from 0 to 2. Okay. And now you can understand from the figure, okay, why this is t5. Let me outside, take it outside. So it will be 0 to 2. Okay. Then it will be limit of y will be 0 to 4 minus 2x. 0 to 4 minus 2x. Now the x square y will be as it is. Now instead of dz we will get z, and you have to put the limit of this, limit of z, 8 minus 2y minus 4x. So it will be 8 minus 2y minus 4x. Okay. Now you should do this integration, okay, with respect to x and y. So now let me integrate with respect to y and put this limit of y. So it will be just now 45 into integration 0 to 2, and it will be 8x square. First term will be 8x square, okay, into y square by 2. So y square by 2, and the limit will be from 0 to 4 minus 2x. From 0 to 4 minus 2. Similarly, next part will be minus 2x square, and y will be y square. So it will be y cube by 3, and your limit will be 0 to 4 minus 2x. And the last part, that is minus 4x cube into you will get y dy. So integration will be y square by 2, and the limit will be 0 to 4 minus 2x. And whatever you will get from here, you have to integrate with respect to x. Okay. Now if you put here 4 minus 2x, here also 4 minus 2x, and here also 4 minus 2x, so what you will get finally, let me give you the result directly. Okay, you do it yourself. So you will get here integration 0 to 2, I think it will be 1/3 x square into 4 minus 2x. So you will get this dx. Now if you put this limit by using, first you have to integrate, then if you put this you will get the result of 128. So please verify this result. Okay, I'm just giving you the concept, how you can proceed, but this is just a simple triple integration that you can do easily. Okay, so first we have to put the limit of z, then you have to integrate with respect to y, put the limit of y, then finally you will get the whole equation in whole integration in terms of x, then you have to integrate it with respect to x, then put the limit, you will get the result. Okay, thank you.